Today we're going to start balancing redox reaction. So redox is reduction, oxidation. Reduction means gain of electrons. Oxidation means loss of electrons. Whenever you have a redox electron reaction, the amount of electrons lost has to equal to the amount of electrons gained. So we're going to have to balance electrons for these types of reactions. In fact, in lab, we're actually going to do a redox reaction titration in one of the labs this semester. So a couple of things. Say I have this reaction right here. Again, I wrote the net ionic equation. I have aluminum solid plus H plus. Again, that means some type of acid. Form aluminum positive 3. And I gave off hydrogen gas. I want to balance it. I'm going to balance the electrons, etc. We're going to do about half reaction method. So a couple of things with this one is I got aluminum and it goes to aluminum positive 3. So again, aluminum starts off at 0. That's its oxidation number. Now it's positive 3. So it's oxidized. So that's going to be one half reaction. So when I do half reactions, I have one that's oxidized and one that's reduced. So this is the one that's oxidized. Couple of things. I got to balance the charges. The way I do it is, well, aluminum here is neutral. That's 0. The charge here is positive 3. I can only add electrons. So if I add 3 electrons here, well, that makes it a negative 3. That makes it neutral. So the sides have to be the same on both sides. It doesn't always have to be 0 and 0, but they have to have the same charges on both sides. So that's the oxidized. On this one right here, this goes from 0, or I'm sorry, this goes from positive 1 to 0. So that's going to be reduction. So this is going to be my reduction side. Before I start doing the electrons, I got one hydrogen here, 2 hydrogens here, so I'm going to put 2H plus. Going to count up my charges. So 2, each one's positive 1. This is positive 2. This is neutral, so that's 0. To balance the charges now. So you always got to add the electrons to the more positive side. I'm going to add 2 electrons. So let me just erase this. Plus 2 electrons. Again, this is reduced. So 2 electrons means minus 2 plus positive 2, they equal the same. So they're the same on both sides. This is where it becomes a little bit different than we were doing before in terms of balancing. I got 3 electrons here, I got 2 electrons here. I got to have the same number of electrons on both sides of the equation, and I want to do about least common multiple. So just to make it simple is, if I multiply everything by 2, I'm going to have 6 electrons. If I multiply this side by 3, I always like to do it over here, I'm going to have 6 electrons, and the electrons cancel out. So what I've done is, I've multiplied a 2 by everything. So 2 times this, that gives me 6 electrons. 2 times 1, again, it's understood to be 1. That gives me 2 aluminum ions, and then 2 times 1 here gives me 2 aluminums. And then the same thing for the bottom. So 3 times 2, this, and then 3 times 1. So got the same number of electrons on both sides. We add these 2 equations together. We cancel what's the same on both sides. In this case, it's the 2, the 6 electrons, I should say. And then I'm going to end up with 2 aluminums plus 6H plus So this is going to be our balanced redox reaction. So let's continue with this. Now a couple of things, these 2 reactions that we're going to do, I haven't had oxygens in there. When we start balancing the oxygens, we're going to have to start adding water, etc. So we'll do that for the final 2 redox reactions. So in this case right here, I go to Cu positive, the Cu, okay, this is half reaction. So I go from positive 1 to 0, and that's actually reduction. So if you remember, if I go from, left to right, that's oxidation, right to left in terms of numbers, that's reduction. And I go from Fe solid, which is going to be 0, and this is positive 3, so that's oxidation. So one gets oxidized, the other one has to be reduced. So I'm going to break these down into half reactions, then we'll go from there. So I've broken down into the half reactions. Now we're going to look at the charges. This side right here is 0. This side is positive 3. Always add electrons to the more positive side. So I'm going to add 3 electrons here. So that makes it 0. So now they're the same on both sides. The same with this. This is positive 1. This is 0. So we always add electrons to the more positive side. So I'm going to add 1 electron. And that's going to make this 0 too. So negative 1 plus 0. So they're the same. Now we got to do least common multiple. This is 3. This is 1. We just have to multiply everything by here by 3 to cancel out the electrons. And always notice it. I always got electrons on the products and on the reactants. That's how this works. And this is how it's going to cancel out. So let me finish it off. So I went ahead and multiplied 3 by everything. So 3 times 1, 3 times 1, and 3 times 1. So I got 3 electrons, 3 copper ions, and 3 coppers. So the electrons are the same on both sides, so we can cancel those out. And then we just write what's left over. And so when I do that, I end up with Fe solid plus 3 copper 1 ions, Fe positive 3, and then 3 copper solid.